This year's College of Science lecture series begins next week with the theme Cosmic Origins. Lectures will focus on modern cosmology insights, triumphs, and timeless mysteries. Here to unravel some of those mysteries is Chris Impey from the College of Science. Welcome. It's good to have you.
Good to be here.
Okay, so define the word cosmology for those of us who are ignorant.
It's very simple. It's the universe and everything in it, past and future.
Okay, so that opens up a lot of questions. And there are 6 lecturers coming on this series. Tell me a little bit about each. Give a thumbnail of what we might expect.
Sure. So for our sort of historical and philosophical overview, we have a Jesuit priest, Guy Consolmagno, and he works at the Vatican Observatory, half-time with us. And he actually has a radio persona as Brother Guy on BBC Radio 5, I think. I've heard him. Very good. So he's going to give an unusual perspective because he's a practicing priest and he's a research scientist, PhD scientist.
Those almost seem exclusive, don't they?
In some religious traditions, they might be. The Jesuits have, always had the latitude to do research, and they kept the calendar for the Pope for a few centuries. And in the past 100 years, they've been able to do research. They have one of the telescopes on Mount Graham, and there's a whole little research group there doing, all sorts of astronomical research.
So talk about some of the other people that we can expect
So then
to
we
see.
have a sort of bookend pair of lectures on the universe, cosmology, Big Bang, the whole enchilada, and that's me sort of setting up the scene and telling us why we should think the universe is 13 billion years old and 50 billion light years across, and why we should believe this story that scientists have told about the universe. And then Mike Turner, who's at the University of Chicago, he's a very famous theorist in the subject, he's going to talk about the stuff we don't quite understand, dark matter, dark energy, the first microsecond after the Big Bang, where we actually amazingly have some information. I mean, we can test this Big Bang idea back to the first fraction of a second, 13 billion years ago. So he's going to talk about that.
And there's little tiny numbers and big numbers that we will understand. And who's next?
And
I want you to introduce me to these people.
Sure. So Mike and I are sort of a tag team on the universe as a whole. And then we have Phil Pinto, one of our own, who's going to talk about where the elements come from. So one of the interesting things about the universe is that it contains life. That's interesting to us. But you can't get life without chemistry, and so Phil's going to talk about where all the chemical ingredients come from, carbon, nitrogen, oxygen, because the universe, as it begins, when Mike and I are doing our cosmology thing, is very simple. It's primordial particles, radiation, basically hydrogen, and that's all. So Phil's going to tell us about this sort of apocalyptic story of stars and how they generate heavy elements and spew them out into space where they might become part of our bodies and so on.
Wow. Okay, number 4.
And then we're up to Furiel Ozel, another one of ours, some very bright young theorist in our department. She's originally from Turkey, and she's going to talk about the enigma of black holes. So one of the things the universe has spawned is black holes, actually all sorts of black holes. Black holes the size of the sun, black holes 1 billion times bigger than that, and she's going to say what we do and don't know about black holes.
Well, I don't know anything, so I can't wait for that one.
Yeah.
So who's number 5?
And so actually that is 5, because I treated 2 people as a bookend. And then we're up to the last, Carolyn Porco, who is sort of almost one of our own. She was on the faculty of planetary sciences. Now she's in Denver, and she's the PI of an instrument on the Cassini mission, which is currently at Saturn. And she's going to talk about the formation of planets and life. What's the landscape for expecting there to be life in the universe?
I'll get back to that question of life, but I was looking on the website about the series, and Joaquin Ruiz, the Dean of the College of Sciences, was quoted as saying that sciences are coming together to reveal the nature of the universe. So maybe you could address that. How are they revealing that? What are the nuts and bolts there?
So the nuts and bolts are, just 20 or 30 years ago, we had a very sketchy idea of cosmology. I mean, we knew the age of the universe and the size roughly. But now with microwave satellites, Hubble Space Telescope, ground-based telescopes, we're painting a whole picture of the universe's origin and evolution, into the details. And also, as I mentioned, as far back as the first fraction of a second, which is kind of amazing that we can say meaningful things about something that happened 13 billion years ago that involved the whole universe. So that's one way. And the other is, say, from the life and planets perspective, we've had these great missions out into the solar system that have found a set of places where you know, we really might even expect life now. So Mars, everyone knows about. Carolyn will probably mention Titan, a moon of Saturn, which her mission has been taking pictures of, and she would probably argue that that's a good place for life 2.0, because Titan is, it's almost Earth-like. It has a thicker atmosphere than we're breathing, made of mostly nitrogen, but it's exotic, it's cold, it has ethane, methane, acetylene, hydrogen cyanide. These things sound evil and toxic, but actually chemists imagine there could be alternative biochemistry there. So she's probably going to provoke us by saying there might be life in the solar system if we look hard enough.
Well, you have also echoed that theme over the years of the, from my interpretation, the firm belief that there are other life forms out there, and what motivates you to pursue that?
Well, so to connect what Carolyn will talk about within our backyard, the solar system, to the cosmic part, I think we believe there are probably half dozen places where there could be microbial life in our solar system beyond the Earth. And that's one planetary system. If you want the big number of how many planetary systems are in the universe, it's 10,000 billion billion.
Oh dear.
So, and then you multiply by another maybe factor of 10 if there are 10 habitable spots. And that's just a crazy number of potentially living worlds, moons and planets. And so then you ask the logical question, could we be the only biological experiment when you have so many possible biological experiments? And most astronomers think, no, that's ridiculous. The numbers are so vast that it's implausible they're all dead. And then the game is on. You know, where can we find the nearest form of life? And that's the exciting research that's going on in astrobiology.
You know, those lecture series are so well attended. That place, Centennial Hall, is packed.
Yeah.
And how do you account for that? What do you think people want to know, and what draws them there?
Right. I mean, it is almost unaccountable, because I compare notes with my colleagues at other big universities, and I say, did you ever have the lecture series? How many people go? I've never heard anyone say 1,000, 1,200, 1,500. So I don't know. I'm proud of us. I'm proud of Tucson. I'm proud of our public to be so interested. So I can't quite explain it, but I think what they are going to get in this series, as they have previous years, is, you know, a real, not any kind of popularized for the masses type presentation. They're getting the top researchers who know how to speak publicly, giving them the state of the art of our scientific knowledge. And I think in Tucson, because of that strong connection to the university, people really want to hear what researchers are finding. You know, they can get the state of the art. They can go for an hour, get this snapshot of a subject they may dimly be aware of, and then maybe afterwards, you know, they can follow some of the web links or do some more reading or maybe take a course. So I think it, you know, it fuels some downstream further interest. That would be the hope, because good science raises more questions than it answers, and I think each of the talks will also do that.
Well, that was my next question, is how do you expect people to take action other than more information? I mean, with all of these scientific discoveries that we're the beneficiaries of these days, we can make more informed decisions. We can take action in different ways. We can reduce our carbon footprint.
Right.
What are your expectations in participating in this series? And I know you were the one who really constructed this series. What are your expectations? What do you think people should take away with this and really employ in their own lives?
Well, that's always a difficult question for cosmology, because the universe is sort of out there and doesn't seem to affect us personally. So it's a little more abstract. It's the idea that whatever you do in your daily job and in your daily life, you know, the research that tells us our place in the universe is relevant. It's relevant to our sense of ourselves and where humanity is going. You know, we're not the most important part of the universe, probably. So I hope people just get the curiosity that goes with continuing to learn that information. I mean, in the Pinto talk, for instance, you will get the information that every carbon, nitrogen, and oxygen atom in our bodies, or the air we're breathing, was part of a star billions of years ago before the sun formed. And, you know, to tell your kids that and know that story is kind of cool. I mean, that's an amazing. So some of the information of science seems incredible, seems amazing, but to understand where it comes from and the research that leads to it, I think it's very empowering. Now, it doesn't actually help you get healthier or wealthier or anything like that. People who do astronomy are resigned to the fact that, it's a little abstract, it's a little remote. But it's part of our intellectual heritage to be able to ask these questions. We are the only species on Earth, I think there are other smart species actually, but we're the only ones that have asked questions about our place in the universe and answered them in a very impressive way.
Well, I certainly look forward to the series. Thanks so much for coming in to talk about it.
Sure, it was a pleasure.